Okay, let's dive right in. Today we're unpacking an incredible explainer based on research from the Swedish AI research firm Disruptivity. We're tracing the monumental journey of Ericsson, an architect of connectivity that began as a humble mechanical workshop way back in 1876 and eventually evolved into the visionary telecommunications powerhouse that fundamentally shapes how our modern world connects.
Here is our roadmap for today. We'll start with the origins of connectivity, pioneer our way through the mobile revolution, and explore the programmable network pivot. Then we'll look ahead to future scenarios with the AI-native future, and finally, wrap up by exploring the industrial metaverse. Basically, we're moving from tangible, historical hardware to the invisible, intelligent networks of tomorrow.
Section 1. The Origins of Connectivity. Let's travel back to those early days in Stockholm, Sweden, where founder Lars Magnus Ericsson laid the groundwork for a global empire. His initial focus was on a very physical, hands-on form of connection.
Now, what's really interesting about this crucial early pivot is how it completely changed everything for the company. Initially, they were just repairing existing telegraph equipment. Nothing too crazy, right? But the real breakthrough happened when they shifted gears to manufacturing their own unique, distinctive, Swedish pattern telephones. By moving away from fixing other people's hardware and instead designing their own superior devices, they secured their very first major contracts. This bold move is literally what sparked their international expansion and set them on the path to true global leadership.
Moving on to Section 2, Pioneering the Mobile Revolution. As we enter the next era, we see the company truly transforming into a global telecom leader. This was an incredibly exciting period, totally defined by pivotal hardware breakthroughs and the creation of fundamental global standards that changed how we all communicate.
We are talking about some massive historical milestones here. They launched the very first fully automatic mobile telephone system and really sparked the digital exchange revolution, vastly improving network efficiency worldwide. They were absolutely instrumental in launching Nordic mobile telephony and standardizing global networks for mobile devices. They even invented Bluetooth technology, which, fun fact, is famously named after an ancient Viking king. All of these breakthroughs were fueled by a continuously growing patent portfolio. This relentless innovation built the rock-solid foundation for every subsequent mobile generation, seamlessly evolving right up to the fifth-generation era we rely on today.
All right, Section 3, the Programmable Network Pivot. This brings us right up to the modern era. The telecommunications infrastructure market has been facing some severe commoditization lately. Hardware alone just isn't enough to maintain an edge anymore, which forced a radical and absolutely necessary strategic shift.
So the crucial point here is captured perfectly in this quote from the Disruptivity strategy report. Transforming from a company that sells boxes to operators to one that provides programmable platforms to ecosystems. This is a huge deal. It's a massive transition from a physical hardware-centric model to a network-as-a-service model. We're talking about tearing down legacy silos and weaving together a software-defined fabric. For you and me, that means networks that can adapt instantly to give us whatever digital experience we need exactly when we need it, without a hitch.
This entirely new operating engine comes to life in 3 strategic steps. Step 1 is to mature current generation network rollouts to build a solid baseline. Step 2 is to integrate programmable telecom APIs, a move they've really accelerated through major strategic acquisitions. And Step 3, this is the true game changer, exposing those network capabilities directly to developers all over the world. By opening up deep network features, like precise location tracking and strict latency guarantees, to external developers, Ericsson is transforming what used to be a simple utilitarian pipe into a highly competitive, high-margin software platform.
Which leads us to Section 4, the AI-native future. Now we're stepping into the futuristic half of our explainer. We are looking ahead to a time where artificial intelligence isn't just some helpful add-on, but is actually integrated directly into the very core of network operations.
And that brings us to agentic AI. Think of this as artificial intelligence integrated directly into the network infrastructure, capable of autonomous, zero-touch, and self-healing management. You might be wondering, why is this so necessary? Well, modern networks generate way too much data for any human engineering team to keep up with. Relying on humans to manually monitor and fix these systems, it's mathematically obsolete at this point. Imagine a network that fixes a dropped connection before your phone even registers a glitch. Self-optimizing software is now a strict, non-negotiable requirement for the future.
This whole concept marks a definitive shift away from manual, reactive engineering models. Instead, we are moving toward proactive, autonomous platforms. These AI-native networks will actually be able to predict hardware failures before they happen and dynamically optimize energy usage on the fly, creating a truly intelligent, self-managing infrastructure. It's like the network has a mind of its own.
Now, all this localized intelligence leads to another truly fascinating development: sovereign AI infrastructure. We're talking about secure, localized artificial intelligence processing deployed right at the network edge to serve highly regulated sectors. Because of geopolitical fragmentation and strict data residency laws, there is a massive new opportunity here. Telecom operators can start offering private AI as a service for sensitive industries like defense, healthcare, and finance. This localized, highly secure approach perfectly positions them to directly rival those massive, centralized cloud hyperscalers.
Let's move to Section 5, exploring the industrial metaverse, and see how this all builds into our final frontier. We are now exploring the wild intersection of upcoming sixth-generation technologies and massive real-world industrial applications. With the advent of sixth-generation networks, we're going to see the deep, seamless integration of sensing and communication capabilities. This is what enables perfect digital twinning, which basically means we can create exact, living, virtual replicas of physical spaces, like entire factories or shipping ports, in real time. Plus, it provides the immense, localized computational power you need to run autonomous robotics fleets in these smart factories. It effectively creates an invisible cyber-physical continuum, seamlessly blending our digital and physical worlds into one interactive environment. It's pretty mind-blowing. Which leaves us with this final provocative thought to chew on. How will a world run by self-healing, invisible networks fundamentally change the very way humanity connects? From a small mechanical workshop repairing telegraphs back in the day to an architect of programmable ecosystems, Ericsson's core mission has always been to make the unimaginable possible. As we look at the vast, untapped potential of this AI-native future, it is absolutely clear that the next chapter of global connectivity is really just beginning.